The idea that the future might be able to influence the past isn't just science fiction. It's a real question that challenges everything we think we know about time and reality. Imagine a world where your choices today could, in some mysterious way, change what already happened yesterday. It sounds mind-bending, but this is the puzzling realm of retrocausality. In this exploration, we'll dive into the strange phenomenon that flips our understanding of cause and effect on its head, revealing a philosophical puzzle that could reshape how we see time itself. Whether you're a science buff, a philosophy lover, or just curious about the universe's deepest secrets, stick around, because the answers might be more surprising than you ever imagined. The concept of retrocausality and its historical context. The idea that the future could influence or determine the past challenges conventional notions of causality rooted in everyday experience and classical physics. In traditional understanding, causes precede their effects in time, creating a straightforward, unidirectional flow from past to future. However, once the boundaries of classical physics expanded with the advent of quantum mechanics, notions like retrocausality gained traction. Early philosophical debates about the nature of time and causality already touched on the possibility that effects might loop back in time. But these ideas gained fresh relevance through developments in quantum theory, particularly in the context of entanglement and non-locality. Physicists and philosophers alike began to question whether the arrow of causality is absolute or if the universe allows for some form of backward influence. Historically, discussions of retrocausality have often been tied to interpretations of quantum mechanics that challenge the classical picture. For instance, the delayed choice experiments, proposed by physicist John Wheeler, demonstrated that decisions made in the present could seemingly affect the behavior of particles in the past. These experiments sparked intense debates around whether the usual arrow of time is an emergent property rather than a fundamental one. Some interpretations, like the transactional interpretation, explicitly incorporate retrocausality by suggesting that waves of influence can travel both forward and backward in time, forming a sort of handshake across space-time. While initially dismissed by skeptics who saw these ideas as metaphysical or speculative, they now serve as a fascinating lens through which to re-examine the relationship between past and future. The philosophical context of retrocausality is equally rich. It touches on deep questions about the nature of reality, free will, and the structure of time itself. Philosophers have long debated whether past and future are equally real or if only the present truly exists, a view known as presentism. Retrocausality seems to challenge presentism by implying that future events might influence what is now considered the present, blurring the boundary between past and future. Conversely, eternalism, which treats past, present, and future as equally real, provides a more compatible ground for retrocausality because it allows events to be part of a four-dimensional space-time block. These discussions also tie into debates over determinism, as retrocausality could imply a universe where causes and effects are intertwined in a more complex web than traditionally assumed, possibly opening pathways for new understandings of free will and randomness. Throughout history, the concept of retrocausality has often been intertwined with science fiction and speculative philosophies, yet it persists as a serious scientific inquiry. Modern theories that incorporate elements of retrocausality tend to aim at resolving paradoxes and inconsistencies within quantum theory, rather than just offering a philosophical puzzle. While no experimental evidence conclusively confirms backward causality, ongoing research in quantum foundations continues to push the boundaries, raising provocative questions about what the universe might truly be capable of. It remains a fascinating crossroads, whether the future can exert influence on the past, or if these notions are merely reflections of our incomplete understanding of the fabric of reality. Scientific perspectives on future influences on the past. Quantum physics introduces intriguing possibilities when it comes to retrocausality, suggesting that effects from the future could influence past events. One of the more compelling proposals related to this idea stems from the behavior of particles at the quantum level, where certain experiments imply non-local correlations that challenge classical notions of causality. For instance, the delayed choice experiment, developed by physicist John Archibald Wheeler, shows that decisions made about measurements in the present can seem to affect the behavior of particles in the past. These experiments imply that the act of measurement today can retroactively determine the outcome of events that were fixed in the past, blurring the lines between cause and effect. In terms of theoretical frameworks, the transactional interpretation of quantum mechanics offers a concrete way scholars have explored these notions. It proposes a standing wave formed by both retarded, forward in time, and advanced, backward in time, waves, which could facilitate information exchange between the future and past. In this view, the universe might be seen as a kind of handshake across time, where influences from the future help resolve quantum events in the past. While still highly speculative, this approach has inspired experimental proposals aiming to detect signals that might carry information from future to past, though definitive evidence remains elusive. Researchers are cautious but optimistic, recognizing that such phenomena could revolutionize our understanding of temporal causality. Additionally, some physicists point to the implications of entanglement to support the possibility of future influences on the past. If two particles are entangled, the measurement of one instantly affects the state of the other, no matter how far apart they are. Extending this phenomenon, some argue that entanglement could be part of a more profound process in which information flows not just spatially, but temporally. If future measurement settings can influence the initial conditions of a system, it suggests a kind of temporal non-locality. Although these ideas are far from conclusively proven, they open fascinating avenues for experimental research. Contemporary experiments are continually pushing the boundaries, testing whether quantum systems can indeed show signs of retrocausality and whether future influences might, in some limited and highly controlled ways, influence past states. Overall, while the mainstream scientific community remains skeptical about the practical reality of retrocausality, ongoing research in quantum mechanics keeps the discussion lively and provocative. Theories and experiments around entanglement, quantum measurement, and the nature of wave functions suggest that our classical intuitions about time may need revision. The potential to manipulate or influence the past through future events would require a radical rethinking of causality, raising questions not only about physics, but also about the fundamental structure of reality itself. Each new study, whether confirming or refuting these phenomena, contributes to a deeper understanding of what the universe might be capable of in terms of influencing its own timeline. Philosophical implications of retrocausality for causation and time. The concept of retrocausality challenges conventional notions of causation by suggesting that effects can influence their causes, particularly in the context of time. Traditionally, cause and effect relationships are understood to flow forward from past events shaping future outcomes. But if the future can somehow influence the past, this raises profound questions about the very nature of causality. Philosophers grapple with whether retrocausality implies that the past is not fixed or that time itself is more fluid than our everyday experience suggests. It opens the door to reconsider how events are interconnected, not as a linear chain, but as a complex web where influence can ripple backward in time. One significant philosophical implication is the destabilization of the classical view of causal asymmetry. In the conventional view, causes precede their effects temporally, which aligns with our experiences of time flowing in a single, unidirectional manner. Retrocausality, however, suggests a picture where this asymmetry might be an emergent property rather than a fundamental rule. For instance, some interpretations of quantum mechanics imply that particles can be entangled in such a way that measurements performed in the present appear to influence the states of particles in the past. If such phenomena have a philosophical counterpart, it questions whether temporal ordering is an absolute feature of reality or simply a practical construct limited by human perception and classical physics. Examples from thought experiments further illuminate the implications of retrocausality for philosophy. Take the famous grandfather paradox, which questions what happens if a time traveler were to prevent their grandfather from having children. Under classical assumptions, this would create a logical inconsistency, erasing the traveler's own existence. Retrocausal models, however, suggest that such paradoxes might be resolved if influences from the future are incorporated into the past in a self-consistent way. This perspective leads to the idea that the future may contain constraints that shape the past in a manner compatible with overall consistency, aligning more closely with some interpretations of quantum mechanics. Ultimately, retrocausality invites us to rethink the fundamental architecture of reality. It urges philosophers to consider whether causation is a symmetric or asymmetric relation, and whether time itself is genuinely unidirectional or more like a four-dimensional block where past, present, and future coexist in a timeless tapestry. If future events can influence past ones, then our linear intuition about history and agency might need revision. The philosophical challenge is to develop a coherent framework that accommodates these insights without collapsing logical consistency or obliterating our experiential certainty about temporal sequence. This ongoing inquiry continues to blur the boundary between physics and philosophy, compelling us to revise long-standing assumptions about the nature of time and causation. Challenges and debates surrounding retrocausal theories. The debate over retrocausality often plunges into complex territory because it confronts our most fundamental understanding of cause and effect. One major challenge is reconciling these theories with the well-established principle of causality that underpins classical physics and everyday experience. Traditionally, causes precede their effects in time, creating a logical flow that aligns with how we perceive reality. Retrocausal models, however, suggest that future events could influence past states, which strains this intuitive framework. For scientists and philosophers alike, the difficulty lies in constructing models that are both mathematically consistent and physically plausible without invoking paradoxes such as the famous grandfather paradox, where future actions seemingly alter past events in ways that negate their own possibility. Debates often intensify over whether retrocausal interpretations are genuinely testable or if they merely shift the problem into a different conceptual space. Quantum mechanics provides some fertile ground for this discussion. Phenomena like entanglement appear to suggest that distant particles can instantaneously influence each other, no matter how far apart they are. Some interpret this as evidence of underlying retrocausal influences that might allow future measurement choices to determine earlier states. Critics, however, argue that such explanations may be violations of locality or could simply be artifacts of the mathematical formalism rather than real phenomena. The question becomes how to distinguish meaningful retrocausal effects from mere mathematical or epistemic artifacts, and whether these effects can be reconciled with or distinguished from non-causal correlations within the theories. Philosophical objections also play a significant role in the debates. Many argue that retrocausality threatens the notion of free will because if the future can influence the past, it raises questions about whether our choices are genuinely autonomous or predestined by future events. Such concerns lead to deep discussions about the nature of time itself, whether it is an objective dimension or a human construct. Some philosophers propose that retrocausality might require rethinking not just physics, but the metaphysical foundations of reality, potentially undermining the linear flow of time itself. Others suggest that retrocausal models are compatible with a block universe view, where all moments in time are equally real, and the distinction between past and future is more about perspective than actual influence. Finally, practical challenges hinder the widespread acceptance of retrocausality in scientific discourse. Testing these theories requires experimental setups capable of detecting influences that seemingly run counter to causality's arrow. While quantum experiments have hinted at the possibility, definitive proof remains elusive. Researchers must design experiments that can rule out alternative explanations, such as hidden variables or non-causal correlations, demanding extraordinary precision and ingenuity. Until such empirical evidence can be reliably obtained, retrocausality remains enshrouded in philosophical intrigue and scientific skepticism, fueling ongoing debates about the very fabric of reality and whether our concept of time might need to be fundamentally reevaluated. The concept of retrocausality, often called backward causation, challenges traditional notions of linear time and causation. Instead of the usual cause-effect sequence, where causes precede their effects. Retrocausality suggests that future events could influence or even determine past states. This idea is sometimes invoked in interpretations of quantum mechanics, where certain experiments imply that particles seem to be affected by measurements that occur later, hinting at a reciprocal influence spanning time directions. The physics involved is complex. Some models propose that quantum entanglement and non-local correlations might be explained if effects can flow backwards in time, without violating relativistic causality. Philosophically, retrocausality pushes us to reconsider our assumptions about temporal order and free will. It raises questions about the nature of causation itself. If the future can influence the past, then causality isn't a one-way street. A famous thought experiment involves probing whether decisions made now could have, in some sense, predetermined past conditions, or whether outcomes we perceive as fixed could be open to influence from future events. Some philosophers argue that this perspective dissolves the rigid boundary we usually place between past and future, suggesting a more interconnected, block universe view where all points in time coexist and influence each other in a web of mutual dependence. Concrete examples from quantum experiments make the idea more tangible. For instance, the delayed choice quantum eraser experiment demonstrates that the decision to observe or erase certain quantum information made after a particle has traveled through an apparatus appears to retroactively change the particle's past behavior. While this doesn't mean the past literally changes in a classical sense, it does imply that quantum states are not fixed until measurement, and the measurement itself influences the historical narrative of the particle's trajectory. This blurs the line between past and future, indicating that in the quantum realm, causality might be more fluid than in everyday experience. From a philosophical standpoint, notions of retrocausality invite debate about determinism and the nature of reality. If future events can shape past conditions, then causality might be more about correlations than about a unidirectional flow of influence. Some thinkers see this as aligning with a holistic universe, where temporal boundaries are constructs rather than features of an objective reality. Others view it as a radical departure from classical causality that challenges the very foundation of how we understand time, morality, and free will. These ideas continue to inspire both scientific inquiry and metaphysical debate, fueling discussions on whether the future possesses a sort of causal power over what was once thought to be fixed. As we wrap up this journey into retrocausality, it's fascinating to see how the idea challenges our conventional understanding of time and causality. We've explored the notion that the future might influence the past, and how this concept isn't just a wild hypothesis, but is rooted in cutting-edge physics and deep philosophical questions. Whether it's quantum entanglement or the way certain interpretations of quantum mechanics suggest a more fluid relationship between cause and effect, the possibilities open up fresh perspectives on reality itself. If this topic sparked your curiosity, just imagine where future research and discussion could lead us. The more we delve into the mysteries of time and causality, the more we realize that our current models are just the beginning. Keep questioning, keep exploring. This isn't just a theoretical puzzle, but a doorway to understanding the universe on a deeper level. Thanks for being part of this conversation. If you want to stay tuned to more mind-bending ideas, unexpected insights, and the latest in philosophy and physics, be sure to subscribe and join us in the next episode. Until then, keep pondering the possibilities, because the future might hold more surprises than we ever imagined.